Hello there, and welcome. I am so glad you have arrived tonight. This is a space for calm thought, for wonder, and for gentle drifting into rest. If you find comfort in these quiet journeys through science and mystery, you are always welcome to return. Simply by listening, you are part of this exploration, and all you need to do is relax. Let your breathing grow slow, let your body feel heavy, and let your thoughts soften like clouds passing across a quiet sky. Tonight we begin a story that stretches across the universe, a story of black holes and the mysteries that surround them. These are not only objects of science but also symbols of wonder, reminders of how vast and strange reality can be. They challenge everything we think we know about space, about time, and about the nature of existence itself. Yet they are also deeply calming to imagine, vast and quiet, hidden in the darkness of the cosmos, shaping galaxies in silence. Long before black holes were confirmed, people wondered about the pull of gravity. The story begins with the simple thought that what rises must fall, that apples drop from trees, that stones thrown upward always return. From this simple observation grew the first ideas of gravity, the invisible force that binds everything together. It holds you gently on the earth, it keeps the moon in its orbit, and it guides the planets around the sun. Without it, the universe would have no structure, only drifting dust and light. For centuries, gravity was thought of as a steady pull, an unseen tether between objects. Then came a deeper understanding when it was realized that gravity is not only a force, but also the bending of space itself. Imagine a fabric stretched out, and imagine a heavy ball placed on it. The fabric curves, and anything moving nearby will follow that curve. This is how gravity works, not as a pull but as a curve in the fabric of space and time. This idea opened a doorway into new mysteries, and at the center of those mysteries stood the possibility of black holes. A black hole begins with a star, a giant burning sun like our own, but far more massive. Stars live for millions or billions of years, burning their fuel and shining across the darkness. But even stars cannot live forever. When the fuel runs out, the star begins to collapse. For smaller stars, this collapse leads to white dwarfs or neutron stars, objects dense and strange, but still visible. For the largest stars, the collapse is unstoppable. Gravity pulls everything inward, tighter and tighter, until no force can resist. The star implodes, and what remains is a black hole. The name itself is simple but powerful. It is black because no light can escape. It is a hole because it swallows everything that crosses its edge. But black holes are not empty. They are regions where matter has collapsed into a point of unimaginable density. Their edges are called event horizons, boundaries beyond which nothing returns. If you were to approach one, you would see the edge glowing with light from gas and dust spiraling inward, but beyond that edge nothing would be visible. What lies inside remains one of the greatest mysteries of all. At the very center of a black hole is the singularity, a point where the rules of physics break down. In theory, all the mass of the star is crushed into this point, smaller than anything we can imagine. Here, space and time are twisted beyond recognition. Equations reach infinity, and our understanding falls short. The singularity is both real and beyond comprehension, a reminder that the universe holds truths that human minds can barely touch. Though black holes sound destructive, they are also creative in their own way. Their gravity shapes galaxies, influences the birth of stars, and drives some of the brightest phenomena in the universe. Around them, matter forms glowing disks, spiraling inward and heating to incredible temperatures. Jets of energy can shoot out from their poles, shining across millions of light years. Paradoxically, black holes which trap light are also connected to some of the brightest events we can see. What makes black holes truly fascinating is how they bend not only matter, but also time itself. Near their edges, time slows. To someone far away, a clock falling toward a black hole would tick slower and slower until it seemed frozen at the edge. For the falling clock itself, time would feel normal, but the journey would be one way. This time dilation is not just science fiction. It is a real effect, one that reminds us how deeply connected space and time are, and how black holes reveal the strangeness of reality. For much of history, black holes were only theoretical, predictions written in equations but unseen. Astronomers wondered if they could truly exist, or if they were only mathematical curiosities. Slowly, evidence began to appear. Stars were found moving in ways that suggested unseen companions. X-rays flared from invisible sources. And most recently, with telescopes powerful enough to capture the faint glow of matter at their edges, we have even seen their shadows, circular windows into the void. Each discovery has brought black holes from mystery into reality, yet they remain just as strange as ever. Imagine for a moment that you are drifting in space, far from the Earth, far from the Sun. Ahead of you lies a black hole, silent and immense. You do not see its heart, but you see the disk of light swirling around it, glowing as matter falls inward. You see the way it bends the stars behind it, curving their light into rings. You feel no pull, for you are far away, but you sense its presence, its quiet gravity holding sway across the cosmos. To imagine this is not frightening but humbling, a reminder of how vast the universe is and how small we are within it. Black holes are often described as destroyers, but perhaps it is better to think of them as keepers of mystery. They hold within them the unanswered questions of physics, the merging of relativity and quantum mechanics, the puzzle of how space and time truly work. They remind us that science is not finished, that there are places where knowledge ends and wonder begins. In this way, black holes are not only objects in space, but also symbols of curiosity, drawing us to explore, to imagine, to dream. As you rest tonight, let the thought of black holes be not a source of fear, but of calm. They are part of the natural cycle of stars, part of the vast balance of the universe. They move silently, they shape galaxies, and they remind us of infinity. They are out there, far beyond our daily lives, distant companions in the sky. To think of them is to drift into the quiet vastness of space, where time slows, light bends, and mysteries unfold. So breathe slowly, let your body sink into comfort, and allow your thoughts to follow the gentle pull of curiosity. Black holes may be dark, but they carry light in their stories. And tonight, those stories can carry you into dreams as endless and mysterious as the universe itself. Imagine for a moment the heart of a dying star, collapsing not in panic, but with quiet inevitability. Here, gravity acts like a patient artisan, pressing inward on atomic structures, stripping away layers of light and matter until density grows unimaginable. In this silent transformation, a black hole is born, a monstrous yet graceful creation shaped when a massive star, perhaps 10 or 15 times the mass of our Sun, reaches the end of its life and collapses inward due to its own gravitational pull. Astronomers like Neil deGrasse Tyson and Brian Cox often invite us to contemplate these cosmic events not as destructive dramas, but as essential architectural steps in the universe's design. Gravity, that gentle sculptor, molds stars into cores so dense that not even light escapes. And as they collapse, these cores become black holes, places where the rules of space and time converge in profound ways. When the star's core collapses, it shrinks so dramatically that the laws of physics start whispering beyond their known boundaries. In this journey inward, the core compresses into a point so small that its density is infinite in theory. That point is called the singularity, though words barely stretch to hold it. Around it lies the event horizon, the boundary beyond which nothing returns. Light, the fastest traveler in the cosmos, cannot cross back once past this line. It is both a limit and a defining edge of the black hole itself. What strikes me most is that black holes are not empty voids, as the name might imply. They are dense wells of gravity, places where matter is packed into astonishing compactness. And yet they are quiet, almost serene from a distance. Brian Cox often reminds us that even the mightiest phenomena in space can appear gentle when viewed through the lens of wonder rather than fear. One remarkable fact, one that seems like a gentle paradox, is that black holes can shrink. Stephen Hawking proposed that black holes are not permanent. They slowly lose energy through something called radiation. Though unimaginably slow, tiny particles escape from the black hole's edge over vast epochs. A black hole might eventually evaporate, fading away in silence over timescales longer than the age of the universe. This idea invites a sense of mystery and closure in one cosmic breath. Another fascinating idea, often mentioned by Neil deGrasse Tyson, is that black holes anchor galaxies at their centers. Supermassive black holes, millions or even billions of times the mass of the Sun, reside in the cores of most large galaxies. Our own galaxy, the Milky Way, dances around a black hole called Sagittarius A, whose mass is several million suns. These black holes seem to influence the stars swirling around them, guiding the motion of trillions of suns with their quiet gravity. Beyond that, supermassive black holes may also power luminous phenomena called quasars. When gas and dust swirl into these dark hearts, they heat up and shine brilliantly across the universe. Light radiates not from the black hole itself, but from the glowing material spiraling inward. In this dance of destruction and brilliance, gravity and light merge in cosmic harmony. The gravitational pull near a black hole is so strong that it radically affects time. From a distance, someone falling in appears to slow and fade, an illusion of time stretching itself into stillness at the edge. Yet the traveler near the edge crosses into darkness in the blink of an eye. This dual experience, simultaneously slow and swift, reminds us that time is elastic in the embrace of gravity. Many of these facts come alive when shared with the gift of wonder. Imagine being able to orbit close to a black hole, circling the event horizon just outside it. The stars would stretch and distort, light bending along extreme curves. The sky would ripple and shimmer. In that dizzying yet beautiful moment, you would see how gravity and light dance together, reshaping space around the void at the center. Despite the enormity and density of black holes, the process that forms them can begin in a gentle whisper. Massive stars fuse lighter elements like hydrogen and helium into heavier ones, creating energy that pushes outward. When the fuel runs out, gravity wins, the outward pressure fades, and the star collapses. This slow fading, leading to a sudden collapse, is the origin of the black hole. It is a recipe written in the elements, a transformation whispered over millions of years, ending in the quiet birth of something vast. If you focus on the life cycle of such a cosmic being, you see both fragility and power. Stars burn their lifeblood over epochs, and yet their collapse is unstoppable once triggered. In that final breath of a star lies the paradox of creation and annihilation, and there is something strangely comforting in that cosmic rhythm. As you breathe now, imagine this calm and silent process unfolding in distant corners of the universe. A star ending its long life, folding in upon itself, disappearing from the sky, yet creating something that will shape galaxies for eons. Though invisible, the presence of the black hole marks the story of forces in time, of death and order, of cosmic balance held in exquisite tension. In this way, the birth of a black hole is not a moment of chaos but of immutable transformation. It is how the universe restructures itself, hides and reveals, challenges and sustains. And in listening to this tale tonight, you are carried into that quiet infinity, invited to dream within space shaped by gravity, carried by the same universe that once shaped stars and now holds them in light's soft embrace. When we imagine black holes, it is tempting to think of them as endless voids or destructive monsters. Yet in truth, they are far more mysterious and elegant than that. They are not holes in the simple sense, and they are not empty. They are regions of space where matter has collapsed into something so dense that gravity has transformed into a sculptor of light, time, and reality itself. In this part of our journey, we explore the anatomy of a black hole, its unseen structure, and the strange effects it has on everything around it. A black hole begins with a boundary called the event horizon. This is the line that separates what can escape from what cannot. Anything that crosses this boundary, whether light, matter, or energy, is forever lost to the outside universe. Imagine a sphere in space, dark and absolute, with an invisible surface where escape is no longer possible. The event horizon is not a physical surface you could touch, but rather a boundary defined by the laws of gravity. To stand near it, if such a thing were possible, would be to watch the universe itself warp around you. Within this boundary lies the singularity, the heart of the black hole. The singularity is where all the mass of the black hole is thought to be concentrated, a point of infinite density and zero volume. In reality, no one truly knows what the singularity looks like, for the laws of physics as we know them break down in that place. It is not only a point in space, but a mystery that reminds us there are still truths about the universe that we have yet to uncover. Scientists like to say that the singularity is both real and unknowable, a paradox sitting quietly at the center of the most powerful objects in the cosmos. Surrounding many black holes is a glowing ring called the accretion disk. This is not part of the black hole itself, but rather matter that has been caught in its gravitational embrace. Gas, dust, and even entire stars spiral inward, heating up as they draw closer. The temperatures in this region can rise to millions of degrees, causing the matter to shine brilliantly in X-rays and other forms of energy. Though the black hole itself is invisible, the accretion disk is one of the brightest sights in the universe, a paradox of light created by darkness. Above and below the black hole, narrow beams of energy sometimes erupt. These are called jets, and they can stretch for thousands of light years, piercing the galaxies around them. It may seem strange that black holes, which swallow light and matter, are also linked to some of the brightest and most energetic events in the cosmos. Yet, it is not the black hole itself that shines, but the matter outside the event horizon, compressed and accelerated until it releases enormous bursts of power. These jets remind us that even the most mysterious objects in space are not only destroyers, but also creators of beauty and energy. Another strange effect of black holes is their influence on time. Near the event horizon, time itself slows compared to the flow of time far away. If you were to watch someone fall toward a black hole, you would see their movement slow down, their clock ticking more and more slowly, until they seemed frozen at the edge. From their perspective, time would feel normal, but for the outside observer, the fall would never be completed. This stretching of time, called gravitational time dilation, is not science fiction. It is a real consequence of the way gravity bends the fabric of space and time. The bending of light is another aspect of a black hole's anatomy. Gravity pulls not only matter, but also light itself. This creates an effect known as gravitational lensing. Stars and galaxies behind the black hole appear distorted, stretched into rings and arcs as their light curves around the invisible mass. From a distance, it would look as though the black hole were wearing a glowing halo, not because it emits light, but because it bends the light of everything behind it. This effect is one of the ways astronomers confirm the presence of black holes, by watching the shapes of background stars twist and shimmer as though space itself were liquid. Black holes also have different sizes and forms. The smallest are called stellar black holes, formed from the collapse of massive stars. These can be only a few times more massive than our Sun, yet they are still dense enough to crush entire worlds within their event horizons. The largest are called supermassive black holes, and they rest at the centers of galaxies. These giants contain millions or even billions of times the mass of the Sun. Their event horizons are vast, wider than entire solar systems. Despite their size, they are quiet guardians of galaxies, holding the stars in their cosmic dance. Between these extremes, astronomers believe there may be intermediate black holes, objects heavier than stellar ones, but lighter than the giants. Their existence is still debated, but their presence may explain certain mysterious patterns of light and gravity. At the other extreme, some scientists suggest that tiny primordial black holes could have formed just after the Big Bang, as the young universe expanded and fluctuated. These would be smaller than mountains or even pebbles, yet still carrying the density of unimaginable mass. Whether such black holes exist is still uncertain, but their possibility stretches the imagination. Perhaps the most incredible aspect of black hole anatomy is that they may not be permanent. In the 1970s, Stephen Hawking suggested that black holes are not completely black. Instead, they slowly emit particles and lose energy, a process now called Hawking radiation. Over timescales longer than the current age of the universe, a black hole could evaporate entirely, vanishing into nothing. The thought that something so immense and powerful could one day simply fade away is both humbling and strangely peaceful. It is a reminder that even the greatest structures of the cosmos are impermanent, subject to cycles of creation and dissolution. To hold the anatomy of a black hole in your mind is to imagine something both terrifying and serene. It has no surface to stand on, no light to see, and yet it has edges, structure, and influence. It shapes the galaxies around it, bends the stars behind it, and slows the clocks of anyone who nears it. Its anatomy is not made of bones or flesh, but of space, time, and energy. In this way, it is both an object and a mystery, both real and unknowable, both part of the universe and beyond our complete understanding. As you let these images drift through your mind, imagine yourself floating safely at a distance from a black hole. See the glowing accretion disk swirling around it, the arcs of light bending from stars behind it, and the quiet circle of the event horizon itself. Feel the calm of knowing that within this darkness lies not only destruction, but also balance, creation, and mystery. Let the thought of this cosmic anatomy soothe you, carrying you gently toward dreams where the universe whispers its secrets, one quiet truth at a time. When we hear the words black hole, we often think first of the giants that anchor galaxies. Yet the most common type of black hole is far smaller, born not from the scale of galaxies, but from the lives and deaths of massive stars. These are called stellar black holes, and though their size is modest compared to their supermassive cousins, they are no less mysterious. To understand them is to follow the life cycle of stars, and to see how endings become beginnings in the quiet rhythm of the cosmos. A stellar black hole begins when a massive star exhausts its fuel. For most of its life, a star is in balance. Gravity pulls inward, trying to collapse it, while the heat of nuclear fusion pushes outward, holding it open. Hydrogen is fused into helium, releasing light and warmth that shine across space. This balance can last for millions or billions of years, depending on the size of the star, but eventually the fuel runs out. When fusion stops, gravity wins. The star collapses inward, and if it is massive enough, nothing can halt the fall. In that moment, a stellar black hole is born. Stellar black holes are typically several times more massive than our Sun. Imagine compressing the mass of 3 suns, or 10 suns, or even 20 suns into a region no larger than a small city. The density is beyond human imagination. To put it into perspective, if the Earth were crushed into the density of a black hole, it would be only a few centimeters across, no larger than a marble. This comparison is not meant to frighten but to illustrate the strangeness of black holes. They are not simply dense objects, they are thresholds where the familiar rules of matter dissolve into mystery. Although black holes cannot be seen directly, stellar black holes reveal themselves through the effect they have on their surroundings. Often they exist in binary systems with another star. The black hole's gravity draws gas and matter from its companion, forming a glowing accretion disk. This disk shines brightly in X-rays, which astronomers can detect from Earth. The discovery of such X-ray sources led to the identification of the first stellar black holes, hidden companions tugging at nearby stars and lighting the darkness with their silent hunger. One of the most famous of these systems is Cygnus X1, a stellar black hole several times the mass of the Sun. It was one of the first candidates confirmed as a black hole, and its discovery marked a turning point in astronomy. Cygnus X1 showed that black holes are not only theoretical constructs but real objects, influencing the stars around them in ways that can be measured and understood. Despite their size, stellar black holes are not cosmic vacuum cleaners that sweep the universe clean. Their gravity is strong, but it only dominates near them. If the Sun were replaced by a black hole of the same mass, the Earth would continue orbiting just as it does now. The only difference would be the loss of sunlight. This fact is often surprising because it shows that black holes are not engines of constant destruction, but natural parts of the cosmic landscape. They are quiet companions, influencing but not devouring everything around them. Stellar black holes also help us explore some of the most profound questions about the universe. By studying the way they bend light, shift time, and emit energy, scientists test the theories of relativity and quantum mechanics. Each stellar black hole becomes a kind of laboratory, an extreme environment where the laws of physics reveal themselves in dramatic ways. In this sense, they are not just remnants of stars, but also tools for understanding the deepest truths of existence. The number of stellar black holes in our galaxy is vast. Astronomers estimate that there may be hundreds of millions of them in the Milky Way alone. Most of these are invisible, wandering quietly without companions, hidden in the darkness. Their presence is inferred from the way stars move, from the flicker of light as matter falls inward, and from the subtle ripples they send through space and time. To think of millions of black holes drifting unseen across our galaxy is humbling, reminding us that the universe is full of secrets just beyond our vision. When two stellar black holes find each other, they may spiral together in a dance that lasts millions of years. As they draw closer, they release gravitational waves, ripples in the fabric of space itself. These waves travel across the universe, reaching Earth as faint signals that can be detected with sensitive instruments. The detection of gravitational waves in recent years has opened a new window into the universe, allowing us to listen to the songs of merging black holes. Each signal tells a story of two stars that lived, died, and collapsed, only to reunite in one final embrace that echoes across eternity. There is also beauty in the idea that stellar black holes recycle matter. The material that falls into them may eventually be lost, but the process of feeding often creates energy that shines far and wide. In some systems, the jets of energy launched by black holes can travel across galaxies, stirring gas and triggering the birth of new stars. In this way, stellar black holes are part of the ongoing cycle of creation and destruction, feeding not only on stars, but also into the making of future stars. Even more mysterious is the thought that stellar black holes may be connected to the fabric of the universe in ways we do not yet understand. Some scientists speculate that they may be linked to dark matter, the unseen mass that makes up most of the cosmos. Others wonder if black holes could be gateways connecting to other regions of space or even other universes. These ideas are speculative, but they remind us of how much there is still to learn and how black holes remain symbols of both knowledge and mystery. To imagine a stellar black hole is to imagine the life cycle of the cosmos written in the language of stars. A star is born, it shines, it lives, and then it dies, collapsing into something new. That new form is not simply an ending, but also a beginning, a silent traveler in the universe that continues to shape and inspire. These objects, hidden yet abundant, are part of the rhythm of creation, destruction, and renewal that defines existence itself. As you let your thoughts drift tonight, picture one of these stellar black holes, born from a massive star long ago. See its invisible presence tugging at a nearby companion, gas spiraling inward in glowing streams, energy radiating outward into space. Imagine the quiet dance of two black holes circling closer, their union sending ripples across the cosmos. And let the thought bring not fear but calm, for these mysteries are part of the natural order, part of the story of the universe that holds us all. Among the countless wonders of the universe, few are more captivating than the supermassive black holes. These are the giants of the cosmos, objects so immense that they anchor entire galaxies in their gravitational grasp. Unlike stellar black holes, which are born from the collapse of massive stars, supermassive black holes hold the mass of millions or even billions of suns. Their event horizons can be as wide as a solar system, and their influence stretches far beyond. To speak of them is to speak of the architects of galaxies, silent and steady rulers of cosmic structure. At the center of nearly every large galaxy that astronomers have studied, a supermassive black hole is found. Our own Milky Way is no exception. At its core lies a black hole called Sagittarius A, containing the mass of about 4 million suns. Though invisible directly, its presence is revealed by the orbits of stars whirling at incredible speeds around a point of darkness. The stars move so fast and so close to what seems like nothing that only a massive black hole can explain their motion. This is the quiet evidence of an immense presence, a dark anchor holding the heart of our galaxy together. The origin of these giants is one of the great mysteries of astronomy. How can a black hole grow so large? One idea is that they begin as stellar black holes that feed on stars and gas over billions of years, slowly increasing in mass. Another possibility is that they formed directly in the early universe from the collapse of enormous clouds of gas, bypassing the smaller stages altogether. Whatever the process, supermassive black holes have been with us almost since the beginning, shaping galaxies even as they themselves were taking shape. Their role in galactic life is profound. Galaxies are not simply collections of stars and dust floating freely. Their structure and rhythm are influenced by the gravity of their central black hole. The stars in the bulge of a galaxy move under its pull, and the vast disks of gas and dust often gather near its influence. Without these immense centers, galaxies might not hold together in the same way. Supermassive black holes are not just passengers in galaxies, they are leaders, guiding the dance of billions of stars with their invisible strength. Supermassive black holes also reveal themselves through some of the brightest phenomena in the universe. When large amounts of matter fall toward them, the gas and dust do not simply vanish. Instead, they form accretion disks that glow with unimaginable energy. Friction and heat cause these disks to radiate, producing light that can be seen across cosmic distances. In some cases, jets of energy erupt from the poles of the black hole, shooting out streams of particles for thousands of light years. These jets are so powerful that they outshine entire galaxies, and yet they are born from the regions surrounding black holes that swallow light. Such luminous objects are called quasars. A quasar is a supermassive black hole feeding so actively that the energy it produces becomes one of the brightest lights in the cosmos. Some quasars shine so strongly that they can be seen from billions of light years away, meaning we see them as they were when the universe was still young. In this way, supermassive black holes serve as beacons across time, allowing us to look back to the earliest chapters of cosmic history. Despite their ferocity, supermassive black holes are often calm. Many of them, including the one in our own galaxy, are relatively quiet today, not consuming large amounts of material. They lie in wait, dark and patient, only occasionally flaring with energy when something drifts too close. Their silence is deceptive, for their influence never ceases. They continue to shape the galaxies they inhabit, even when invisible and still. Another astonishing truth about these giants is the relationship between their size and the galaxies that surround them. Astronomers have discovered that the mass of a supermassive black hole is linked to the mass of the galaxy's central bulge of stars. This suggests a deep connection, as if the growth of the black hole and the growth of the galaxy are intertwined. The black hole feeds the galaxy with energy, while the galaxy feeds the black hole with matter. This balance between growth and restraint shapes the evolution of both, a cosmic partnership that has endured for billions of years. The thought of such enormous objects can be difficult to grasp. Imagine an object so massive that light itself cannot escape, yet so compact that its power is hidden behind an invisible horizon. Imagine its event horizon stretching as wide as the orbit of Neptune or Pluto, encompassing space where planets and stars could once move freely. Imagine its gravity so intense that it bends not only light but time, slowing the clocks of anything that strays too near. And yet, despite all this, imagine it lying quietly at the heart of a galaxy, a silent ruler never seen directly. Supermassive black holes also remind us of how small we are. The Earth, the Sun, and even the Milky Way itself are tiny compared to the scale of these giants. Their lifetimes stretch beyond comprehension. While stars live for billions of years, supermassive black holes may endure until the universe itself fades into silence. To think of them is to feel the weight of time and space pressing gently against the mind, a reminder that the cosmos is vast beyond measure and that our place within it is but a brief and delicate moment. There is also wonder in knowing that we have glimpsed them directly. In recent years, astronomers captured the first image of the shadow of a supermassive black hole, a glowing ring of light surrounding darkness at the heart of a distant galaxy. To see this was to confirm what had once been only theory. The photograph was not just a scientific achievement. It was a moment of awe, a vision of something humans had imagined for centuries finally brought into view. It was proof that the universe can be both known and mysterious at the same time. As you imagine supermassive black holes tonight, picture them not as destroyers, but as creators of balance. Picture them anchoring galaxies, guiding stars, shaping the rhythm of cosmic evolution. Picture them glowing with the brilliance of quasars, their light crossing billions of years to reach us. Picture them lying silent at the heart of galaxies, dark and steady, waiting. Let the thought of them bring calm rather than fear. For they are not monsters but guardians, holding galaxies together with the quiet hand of gravity. And as you rest, remember that the same universe that holds these giants also holds you. You are made of the same matter that feeds them, of the same elements born in the hearts of stars. To think of supermassive black holes is to think of yourself as part of something greater, woven into the same fabric of space and time. Let that thought soothe you, carrying you gently into dreams, where galaxies turn, stars shine, and the silent giants at their hearts keep watch, steady and eternal. When we think of black holes, we often imagine the small stellar ones born from dying stars, or the enormous supermassive ones that anchor galaxies. But the story of black holes may also include more elusive forms, those that lie between or below these familiar extremes. These are the intermediate black holes, mysterious beings that may bridge the gap, and the tiny primordial black holes that may have been born in the earliest moments of the universe. Together they add depth and intrigue to the already mysterious world of gravity's most powerful creations. Intermediate black holes are thought to be larger than stellar black holes, but far smaller than supermassive ones. While stellar black holes usually contain the mass of a few suns and supermassive black holes contain millions or billions, intermediate black holes may hold a few hundred or a few thousand suns. They are the missing link, the middle chapter in the story of black hole growth. Yet despite their theoretical importance, they remain among the most difficult to find. One reason intermediate black holes are so elusive is that they do not announce themselves loudly. Supermassive black holes reveal their presence through quasars and jets that blaze across the universe. Stellar black holes often give themselves away by pulling matter from companion stars. Intermediate black holes may do neither. They may lie quiet, drifting in the outer reaches of galaxies, or hiding within dense star clusters. Their quietness makes them invisible, yet their existence is needed to explain how black holes grow from small to large. Some evidence suggests they may be hiding in globular clusters, those ancient swarms of stars that orbit galaxies like bees around a hive. In these dense regions, stars collide and interact, and smaller black holes may merge into larger ones. Over time, such mergers could form intermediate black holes. Observations of unusual star movements and X-ray bursts have hinted at their presence, though certainty remains just out of reach. The search for them continues, driven by the belief that they are the natural stepping stones in the growth of the universe's giants. Beyond these middle beings lies another mystery, that of primordial black holes. Unlike stellar or supermassive black holes, which form from stars and galaxies, primordial black holes are thought to have been born in the earliest moments after the Big Bang. In that chaotic infancy, the universe was filled with wild fluctuations of energy and density. Some regions may have collapsed under their own weight, forming black holes of many different sizes, some as large as mountains, others as small as grains of sand. If they exist, primordial black holes would be unlike any others. They would not be tied to the life cycle of stars, but to the birth of the cosmos itself. They might drift through space unnoticed, tiny yet powerful, reminders of a time before galaxies and stars, when the universe was still finding its shape. Some theories even suggest that primordial black holes could make up part of the mysterious dark matter, the unseen mass that outweighs visible matter in the cosmos. To think that the invisible scaffolding of galaxies might be made of countless ancient black holes is a thought both strange and beautiful. Miniature black holes, whether primordial or created by other processes, carry unique possibilities. Because of Hawking radiation, the smaller a black hole is, the faster it evaporates. Large black holes may take longer than the age of the universe to fade, but tiny ones could disappear much more quickly. If primordial black holes were small enough, many of them may already have evaporated, releasing bursts of energy as they vanished. The universe may still hold faint echoes of these disappearances, subtle signals waiting to be discovered. The concept of miniature black holes has also inspired bold speculation about physics itself. Some scientists wonder if such black holes could form in high-energy environments, perhaps even in particle collisions. These ideas remain theoretical, but they reveal the allure of black holes as laboratories for the most extreme experiments nature can imagine. They remind us that the cosmos holds not only grandeur on enormous scales, but also secrets in the tiniest of realms. Intermediate and miniature black holes show us that the universe is not only about what we can see, but also about what may remain hidden. They may drift silently through space, unseen but influential, shaping the paths of stars, stirring the seas of galaxies, or quietly disappearing into nothingness. Their existence, though uncertain, expands the horizon of possibility, showing us that nature is often richer than our imagination. It is easy to picture the drama of supermassive black holes or the fierce hunger of stellar ones, but there is also something soothing in thinking of these quieter companions. Imagine an intermediate black hole resting within a star cluster, its gravity holding the cluster together unseen yet steady. Picture a primordial black hole drifting through the darkness, older than any star, a relic from the birth of time itself. These images carry not fear but calm, reminding us of the quiet endurance of the cosmos. The search for these black holes is ongoing, with astronomers using every tool they can. They watch for unusual star movements, for subtle ripples in space from mergers, for faint bursts of light that could signal their presence. Each hint brings us closer to confirmation, but even if they remain elusive, their possibility itself enriches our understanding. The idea that the universe may be filled with hidden black holes is comforting in its own way. It tells us that there are still mysteries waiting, still stories unfolding, still corners of reality we have yet to explore. As you rest tonight, let your imagination drift to these unseen beings. Think of the intermediate black holes lying between the small and the great, quiet bridges across scales of existence. Think of the primordial black holes, ancient and enduring, perhaps drifting near us even now, unnoticed in the vastness of space. Think of miniature black holes, evaporating with tiny bursts of light, whispering of impermanence even in the deepest darkness. The universe is not only vast in size but also rich in variety. Black holes come in many forms, from giants larger than solar systems to tiny points that may vanish in a breath of cosmic time. Each kind reveals something different about the nature of gravity, of matter, and of time itself. To know that these possibilities exist is to feel the fullness of the universe, a fullness that comforts rather than overwhelms. So let these thoughts settle in your mind like stars fading into night. Remember that even the quietest and most hidden black holes are part of the same great story, the story of a universe both mysterious and beautiful. And as you close your eyes, let yourself drift into that mystery, held gently by the thought of cosmic possibilities, safe within the endless calm of space. Black holes are defined by their invisibility. By their very nature, they allow no light to escape, hiding their presence behind the veil of gravity. Yet, despite this, astronomers have learned to uncover them, not by seeing them directly, but by observing the effects they have on the world around them. It is a little like knowing that the wind exists, not because you can see it, but because you can watch the trees bend and hear the leaves rustle. With black holes, the universe provides clues, and by following them patiently, we come to know what cannot be seen. One of the earliest and most powerful clues comes from the way stars move. In many systems, a star seems to orbit something invisible. By measuring its speed and its path, astronomers can calculate the mass of the hidden companion. If the object is too massive to be a normal star and too small to be a cluster of stars, the only explanation left is a black hole. This method revealed some of the first strong candidates, stars circling invisible partners, their motion betraying the presence of a dark neighbor. Another clue comes from the light of X-rays. When a black hole has a companion star, it often feeds on gas drawn from that star. As the gas spirals inward, it forms a disk that heats to incredible temperatures, glowing brightly in X-rays. These X-rays can travel across space, reaching telescopes on Earth or in orbit. To detect them is to catch a glimpse of the feeding habits of a black hole. It is not the black hole itself that shines, but the material falling toward it, lighting up in its final moments before crossing the event horizon. In more recent times, astronomers have learned to use the ripples of space itself to detect black holes. When two black holes orbit each other and eventually merge, they create waves in the fabric of space and time. These gravitational waves travel outward like ripples on a pond, carrying with them the story of the collision. Sensitive instruments on Earth can measure these faint vibrations, and each detection is like hearing the echo of a cosmic event that happened billions of years ago. It is as if the universe is whispering its secrets through the trembling of its own fabric. Another way to find black holes is through the bending of light. Gravity does not only affect matter, it also bends light itself. When a black hole lies between us and a distant star, the light from that star can be curved, forming strange arcs or rings in the sky. This phenomenon, called gravitational lensing, allows us to infer the presence of black holes even when they are otherwise invisible. In this way, black holes act like natural lenses, distorting the view of the universe behind them, creating images that look like mirages, but are in fact glimpses of truth. One of the most extraordinary achievements in modern astronomy has been the creation of an image of a black hole's shadow. Using a network of telescopes spread across the globe, scientists were able to combine their observations to see the glowing ring of matter around a supermassive black hole. At the center of that ring was a dark circle, the shadow of the event horizon itself. To see this was to confirm what had once been only theory, a picture of something that by definition should never be visible. It was not only a scientific milestone, but a reminder of human curiosity and persistence. Even when we cannot take pictures, we can learn about black holes by listening to the light they do not release. Astronomers study the energy and signals that disappear into the darkness. By watching the way stars flicker, the way gas clouds move, and the way galaxies shine, they piece together the story of hidden giants. Each piece of missing light is a clue, and each clue deepens our understanding of the cosmos. There are also more subtle signs. In the centers of galaxies, stars move with incredible speed, circling an unseen mass. The faster they move, the greater the mass must be. These stellar dances reveal the presence of supermassive black holes. The stars themselves become messengers, carrying news of the darkness they orbit. By carefully measuring their orbits, astronomers can weigh the invisible object at the center, confirming that it is millions or billions of times the mass of the Sun. The beauty of these methods is that they turn invisibility into presence. Black holes do not reveal themselves willingly, but the universe cannot hide their influence. Gravity is a sculptor that leaves fingerprints everywhere, from the motions of stars to the bending of light, from the heating of gas to the trembling of space. To detect a black hole is to follow those fingerprints, to trace the outline of something that is always hidden yet always there. There is something soothing in this pursuit. It reminds us that truth does not always appear in direct sight. Sometimes it is found in the gentle effects, the quiet influences, the hints left behind. Just as we know the wind from the swaying of the grass, we know black holes from the swaying of the stars. Just as we know the presence of air from the breath it gives us, we know the presence of black holes from the energy they release when matter falls inward. These parallels bring the distant universe closer to our own experience, making it feel less alien and more familiar. The detection of black holes also reminds us of the power of patience. Some of these observations take years or even decades. Astronomers wait for stars to complete their orbits, for ripples to pass through their instruments, for faint signals to rise above the background noise. The universe does not reveal its secrets quickly. It speaks slowly across vast spans of time. Yet in listening carefully, we find that it does speak, and it tells stories of unimaginable scale and beauty. As you imagine this tonight, think of the universe as a grand stage where black holes play the part of silent actors. They never step into the light, but their presence is felt in every movement around them. The stars that whirl, the gas that glows, the space that trembles, all point to their existence. Our role is simply to observe, to watch the patterns, and to let the invisible become known through its influence. Let these images soothe you. Picture the stars orbiting an unseen companion, their graceful dance tracing the outline of a hidden giant. Picture gas spiraling inward, glowing brightly in X-rays before vanishing into silence. Picture ripples spreading across space, subtle tremors carrying the news of a cosmic embrace. Picture light bending into rings and arcs, the universe itself painting around the shadow of a black hole. These are not signs of menace, but signs of wonder. Soft reminders that the cosmos holds mysteries that can be touched, even when they cannot be seen. As you rest, let the thought of this hidden detection comfort you. Know that even the darkest places in the universe leave traces of their presence, and that with patience and care those traces can be followed. Black holes are invisible, yet they are not absent. They are quiet, yet they speak through the stars, through the light, through the fabric of space itself. And in listening to them, you are connected to the great mystery, carried gently into the calm expanse of the cosmos. Among the strangest and most beautiful aspects of black holes is their ability to reshape time itself. We are used to thinking of time as steady and dependable, a constant rhythm flowing forward moment by moment. We measure it with clocks, we live by it each day, and we expect it to move at the same pace for everyone. Yet near a black hole, this familiar flow becomes strange. Time slows, stretches, and bends in ways that defy our everyday sense of reality. To imagine this is to step beyond the boundaries of human experience and into the mysteries of relativity. The story begins with the realization that space and time are not separate. They are woven together into a fabric called space-time, and gravity is the bending of that fabric. The stronger the gravity, the more space-time bends. Near a black hole, gravity is so strong that it twists space-time into extreme shapes. This twisting affects not only the paths of objects and light, but also the very flow of time. For someone far away, time continues as usual. For someone near the edge of a black hole, time ticks more slowly. Imagine for a moment two friends, one drifting safely in open space and another daring to approach a black hole. For the traveler near the black hole, time feels normal. Their heart beats at its usual pace, their clock ticks steadily, and their thoughts move as they always do. But for the friend watching from a distance, everything changes. They see the traveler's movements slow, their clock tick more slowly, their signals stretch into longer and longer wavelengths. As the traveler approaches the event horizon, they appear to freeze in time, suspended at the edge of darkness. This effect is called gravitational time dilation, and it is not merely a theory. It has been confirmed in smaller ways right here on Earth. Satellites in orbit experience slightly different rates of time compared to clocks on the surface, and engineers must account for this difference when designing systems like global positioning networks. If gravity on Earth can alter time in such small yet measurable ways, then imagine the effect near a black hole, where gravity is millions or billions of times stronger. The slowing of time near a black hole is not only fascinating but also strangely comforting. It shows us that the universe is flexible, that time itself is not rigid but shaped by the forces of nature. It invites us to think of time not as a constant march, but as a river that can flow faster or slower depending on where you are. In this sense, black holes are not only destroyers of matter, but also teachers, revealing the hidden nature of time. There are even more curious consequences of this time bending. Suppose the traveler who approached the black hole could somehow turn back before crossing the event horizon. For them, only a few hours or days might have passed, but for their distant friend, perhaps centuries or millennia would have gone by. The traveler would return to a universe changed beyond recognition, a future they skipped simply by lingering in the gravity of the black hole. This idea has long inspired writers and scientists alike, for it suggests that black holes are natural time machines, carrying travelers into the future simply by altering the flow of time. Of course, crossing the event horizon itself is another story. Once beyond that boundary, all paths lead inward. Space and time are so distorted that moving forward in time is the same as moving deeper into the black hole. There is no return, no way to come back to the outside universe. For the traveler, the journey continues quickly toward the singularity, where the laws of physics break down. For the outside observer, however, the traveler remains frozen forever at the edge, their image stretched and faded until it vanishes into darkness. This dual story, two perspectives both true, reveals the strangeness of black holes and the relativity of time itself. Light, too, is affected by this bending of time. As light escapes from near the event horizon, it stretches into longer and longer wavelengths, shifting from visible colors into infrared and radio waves. To a distant observer, the glow of matter near a black hole fades and reddens, a phenomenon called gravitational redshift. It is as though the black hole is not only swallowing matter, but also draining the energy from light itself, stretching it thin as it climbs out of gravity's well. Even more fascinating is how black holes bend our understanding of causality, the sequence of cause and effect that underlies everything we know. Near a black hole, the flow of events is twisted, with some paths leading to futures we cannot see. The closer one gets to the singularity, the more uncertain and extreme this becomes. It is here that relativity and quantum physics clash, each offering hints but no complete answers. Black holes sit at the boundary of knowledge, where time itself resists simple explanation. There is beauty in this strangeness. To imagine time slowing and stretching is to imagine the universe whispering that there are deeper rhythms than the ticking of clocks. It is to imagine that time is not a straight line, but a vast landscape with valleys and peaks shaped by gravity. Black holes are the most dramatic sculptors of this landscape, carving out regions where time nearly stands still, where moments are stretched into eternity, and where the future and past blur together in ways that challenge imagination. This bending of time also gives us a new way to think about ourselves. If time can flow differently in different places, then our lives are not fixed in a single universal rhythm. Each of us already experiences time uniquely, not only in relativity, but in perception. Moments of joy seem to pass quickly, while moments of waiting stretch endlessly. Near black holes, this subjective experience is echoed in physical law, reminding us that the universe is not rigid, but alive with change. As you let these thoughts drift through your mind, picture yourself watching a black hole from a safe distance. See the glowing ring of its accretion disk, matter spiraling inward, time itself slowing as it approaches the edge. Imagine a clock falling toward the event horizon, its hands ticking slower and slower until they seem to stop. Imagine signals stretching into whispers, light fading into darkness, and the whole scene moving as though time itself were being painted with a softer brush. In this vision, there is no fear, only awe. The bending of time is not chaos but order, the natural expression of gravity at its strongest. It is the universe reminding us that everything is connected, that space and time are one, and that even something as familiar as the passage of moments is more mysterious than we know. To rest with this thought is to rest with the wonder of existence itself, letting the strange beauty of black holes carry you gently into dreams. When we think of black holes, we often picture silence and darkness, objects that swallow all light and give nothing back. Yet one of the most surprising truths about black holes is that they are also among the most energetic objects in the universe. They may trap light within their event horizons, but the matter that surrounds them often shines brighter than entire galaxies. Their presence is revealed not only through gravity, but also through the immense energy they release, energy that shapes the cosmos in ways both subtle and spectacular. The most familiar form of this energy comes from the accretion disk, the glowing ring of gas and dust that spirals into the black hole. As matter falls inward, it collides with itself, compresses, and heats to incredible temperatures. The process is not gentle but violent, creating radiation that can be seen across vast distances. This light is not from the black hole itself, but from the material in its grasp, shining fiercely as it approaches the event horizon. In some cases, the energy released by an accretion disk outshines the combined light of billions of stars, making black holes paradoxically some of the brightest objects in existence. Jets of energy add another layer to this paradox. In many systems, black holes launch narrow streams of particles from their poles, jets that can travel for thousands or even millions of light years. These jets move at nearly the speed of light, carrying energy far from the black hole and shaping the galaxies around them. No one fully understands how these jets form, but they are thought to be powered by the twisting of magnetic fields in the extreme environment near the event horizon. What is certain is that they can transform galaxies, stirring gas, slowing or speeding the formation of stars, and even regulating the growth of galaxies themselves. One of the most fascinating forms of energy associated with black holes comes from a prediction made by Stephen Hawking. He proposed that black holes are not completely black, but instead slowly leak energy through a process now called Hawking radiation. This radiation arises from quantum effects near the event horizon, where particles and antiparticles briefly appear and then vanish. If one particle falls into the black hole while the other escapes, the black hole loses a tiny bit of mass. Over unimaginable timescales, this process would cause a black hole to evaporate entirely, disappearing into nothing. For large black holes, this evaporation is so slow that it is practically invisible. A supermassive black hole would take longer than the age of the universe to fade. But for tiny black holes, such as those that may have formed in the early universe, Hawking radiation could play a significant role. Some might already have vanished, leaving only faint echoes of their disappearance. Others may still be evaporating now, releasing bursts of energy in their final moments. The idea that even black holes can one day end is both humbling and reassuring, a reminder that nothing is truly eternal, not even the most powerful objects we know. The energy released by black holes is not only spectacular, but also deeply useful to science, By studying the radiation from accretion disks and jets, astronomers learn about the conditions near the event horizon. By measuring the X-rays and gamma rays they emit, they test theories of relativity and quantum mechanics in ways impossible to replicate on Earth. Black holes become laboratories of extremes, places where energy and gravity push physics to its limits. Each photon of light they release carries information, a message from the edge of the unknowable. Black holes also reveal their energy in the ripples they send through space and time. When two black holes merge, the collision releases more energy in the form of gravitational waves than all the stars in the universe produce in light during the same moment. These waves spread outward, carrying the story of the merger across billions of light years. On Earth, sensitive instruments detect these faint tremors, and with each detection we gain insight into the invisible ballet of black holes. The fact that we can listen to these ripples is itself a marvel, a way of hearing the universe speak in a language of energy and gravity. It is a strange truth that black holes, which consume matter and trap light, are also among the engines that power the cosmos. Their energy feeds galaxies, ignites quasars, and shapes the birth of stars. They are both destroyers and creators, both silence and song. This duality gives them their beauty. They remind us that even in darkness there is light, and even in the deepest silence there is a kind of music, played not with sound, but with the fabric of the universe itself. When you think of this energy, do not imagine chaos or violence, but instead picture balance. Imagine the accretion disk glowing like a soft lantern in space, its light reaching across the void. Imagine jets stretching outward like cosmic beacons, guiding the growth of galaxies. Imagine gravitational waves rippling gently through the cosmos, their vibrations carrying news of distant events. Imagine Hawking radiation slowly, patiently whispering away the mass of a black hole across billions of years. Each of these is a different form of energy, a different expression of the same mysterious power. To rest with these images is to rest with the thought that the universe is filled with paradoxes. Darkness creates light, silence creates sound, destruction creates creation. The energy of black holes is not frightening but inspiring, a reminder that the universe does not fit into simple categories of good or bad, safe or dangerous. Instead, it is vast, balanced, and endlessly creative. As you drift tonight, let yourself imagine that you are floating near the edge of one of these luminous black holes. See the glowing disk swirling with color, feel the jets racing outward into infinity, listen for the faint whisper of gravitational waves passing by. Know that even the darkest objects in the universe give back to the cosmos, shaping it with their energy, guiding its evolution, and reminding us of its beauty. Let that thought soothe you, carrying you into dreams where light and darkness are not opposites but partners, weaving the fabric of existence together in harmony. Black holes may seem like solitary objects hidden away in darkness, but in truth, they are deeply connected to the galaxies that surround them. In many ways, galaxies and black holes grow together, shaping and guiding each other across billions of years. The relationship is not simple. It is a conversation written in gravity and light, in energy and silence, in cycles of creation and destruction. To understand galaxies, we must understand black holes. To understand black holes, we must look to the galaxies that cradle them. At the center of nearly every large galaxy, astronomers have discovered a supermassive black hole. These giants contain millions or even billions of times the mass of the Sun. They do not sit idly. Their gravity influences the motion of stars and gas across the galaxy. In the bulge at the center, stars move in patterns that reveal the presence of the hidden mass. Without such central anchors, galaxies might not hold their shapes. Black holes are not only part of galaxies, they are their hearts, steady and invisible, guiding their evolution. One of the most remarkable discoveries in modern astronomy is the link between the size of a galaxy's central bulge and the size of its central black hole. This suggests that as galaxies grow, their black holes grow with them. When gas and dust fall into a black hole, the energy released can blow winds outward, stirring and sometimes clearing the galaxy's central regions. These winds can stop new stars from forming or trigger their birth in bursts of energy. In this way, the black hole regulates the galaxy, neither consuming too much nor too little, but keeping a balance. Quasars are dramatic examples of this balance. These are galaxies with supermassive black holes that are feeding actively, pulling in huge amounts of matter. As the matter spirals inward, it shines so brightly that it outshines the entire galaxy around it. Some quasars can be seen from billions of light years away, meaning we see them as they were when the universe was still young. Their brilliance reveals not only the black hole itself but also the growth of galaxies in those early times. It is as if the universe left lanterns burning in its youth, guiding us back to its beginnings. The energy from a feeding black hole does not stay at the center. It travels outward in the form of radiation, winds, and jets. These flows can reach across tens of thousands of light years, stirring the gas that forms stars. In some cases, the energy suppresses star formation by heating the gas and preventing it from collapsing. In other cases, the pressure triggers new waves of star birth. In either case, the black hole is not just a consumer. It is a gardener, pruning and planting, shaping the galaxy like a careful hand in a vast cosmic garden. Even galaxies themselves can be shaped by the encounters of their black holes. When galaxies collide, their central black holes spiral toward each other, eventually merging into a single, larger one. This process releases enormous energy in the form of gravitational waves that ripple through the cosmos. But the merger also reshapes the galaxy, redistributing stars and gas, creating new structures, and sometimes igniting bursts of star formation. The growth of black holes and the growth of galaxies are intertwined, bound together by these cosmic encounters. Our own Milky Way is an example of this partnership. At its heart lies Sagittarius A, a black hole with about 4 million times the mass of the Sun. Most of the time it is quiet, consuming very little. But occasionally it flares, releasing energy as gas orbits near its event horizon. These flares remind us that even when silent, the central black hole is active, influencing the galaxy in ways that may not always be visible. It sits at the core of the Milky Way, unseen yet essential, guiding the stars around it like a conductor guiding a vast cosmic orchestra. The relationship between black holes and galaxies also reminds us of the scales of time involved. Galaxies live for billions of years, growing, colliding, and changing. Black holes grow alongside them, feeding slowly over ages, shaping the conditions for future stars. The balance between feeding and resting is delicate, but over time it creates the galaxies we see today. To imagine this is to imagine a slow dance, each partner moving in harmony with the other, each shaping the other's steps across the stage of the cosmos. The influence of black holes is not limited to their immediate surroundings. Their jets and winds can reach into intergalactic space, carrying energy and material across vast distances. These outflows may help spread heavy elements created in the hearts of stars into the wider universe. In this way, black holes contribute to the cycle of matter, ensuring that elements essential for planets and life are carried far and wide. They may seem like destroyers, but in truth, they are also distributors, spreading the seeds of creation across the cosmos. The presence of black holes in galaxies also speaks to the unity of the universe. We often think of stars, planets, and galaxies as separate from black holes, as though they were different categories of objects. But in reality, they are all part of the same story. Stars live, die, and collapse into black holes. Black holes shape galaxies. Galaxies give birth to new stars. The cycle continues endlessly, each part feeding into the next, each step both an ending and a beginning. To hold this image in mind is to see the universe as an intricate web of connections. Black holes do not exist in isolation. They are part of galaxies, and galaxies are part of the universe, and we are part of it all. The same forces that shape galaxies also shape us. The same elements scattered by black holes into space are the elements that form our bodies. In this sense, we are not only observers of the cosmos, but participants in its story, woven into the fabric of space and time. As you drift into rest tonight, imagine a galaxy seen from afar, a spiral of stars glowing softly in the dark. At its heart, unseen yet powerful, rests a black hole, guiding the motion of billions of suns. Picture the energy flowing outward, stirring clouds of gas, triggering the birth of stars, shaping the galaxy with steady hands. Imagine the long ages of growth and change, the slow dance of galaxies colliding, the merging of black holes, the birth of new stars from the ashes of the old. Let the vision calm you, for it tells us that the universe is not chaos, but balance, not emptiness, but fullness, not destruction, but creation in endless cycles. In this vision, you are part of the galaxy too, a small spark of consciousness carried on a planet that orbits a star, which itself moves around a black hole. You are connected to the same rhythm, to the same story. And in that connection, you can find peace, knowing that you belong to something vast and beautiful, a universe where even the darkest hearts shine with energy and purpose. One of the most captivating ideas connected to black holes is the possibility that they may serve as gateways. While science has no proof that such passages exist, the mathematics of relativity leaves open the possibility of bridges through space and time. These ideas are sometimes called wormholes, tunnels that might connect distant regions of the universe or even entirely separate universes. To think about them is to step into a realm where science and imagination meet, where the mysteries of black holes touch the edges of dreams. The concept of a wormhole arises naturally from the mathematics of general relativity. If space and time are like a fabric, then gravity is the bending of that fabric. Imagine folding the fabric so that two distant points touch. A wormhole would be a tunnel through that fold, a shortcut across space and time. The entrances to such tunnels might resemble black holes, with immense gravity pulling inward, yet on the other side there could be another universe, another galaxy, or perhaps another point in time. The thought is speculative, but it is rooted in real equations that describe the shape of space-time. If black holes are connected to wormholes, they would not only consume, but also connect. A traveler might enter one side and emerge far away in an instant, crossing distances that would otherwise take millions of years. To imagine this is to imagine the universe as a vast web of paths, some long and winding, others hidden and direct. Black holes could be the entryways to these hidden roads, though we do not yet know whether such roads truly exist. One of the challenges with wormholes is stability. The fabric of space-time is not easy to pierce or tunnel through. The intense gravity of a black hole tends to close the passage almost as soon as it forms. To hold a wormhole open would require exotic forms of energy, materials with negative pressure or negative mass, things that have never been observed. Without such stabilizing forces, any wormhole would collapse too quickly to be useful. In this way, wormholes are reminders of how imagination can run ahead of evidence, but also of how evidence sometimes follows imagination. Many discoveries began as dreams that seemed impossible until proof was found. The idea that black holes could connect us to other universes is equally intriguing. Some scientists speculate that each black hole might give birth to a new universe inside it. The singularity, rather than being a dead end, might be the seed of a new cosmos, expanding beyond its event horizon in a realm separate from ours. If this is true, then our own universe might have begun in the heart of a black hole in another, larger universe. This possibility cannot yet be tested, but it offers a comforting symmetry. Endings and beginnings may be more closely tied than we know. Even within our own universe, the thought of wormholes and gateways helps us think differently about distance. The stars we see at night are impossibly far away. Even the nearest star is light years from Earth, and the scale of galaxies is beyond human travel. Wormholes, if they exist, would change that scale. They would allow movement across the cosmos not in thousands or millions of years, but in moments. To imagine standing on Earth and stepping through a tunnel to emerge in another galaxy is to imagine a future where the universe itself feels smaller and more connected. These ideas also remind us of the mysteries of time. If wormholes can connect places, perhaps they can also connect moments. Relativity allows the possibility of closed loops in space-time, paths that return to earlier points. If a traveler could move through such a loop, they might experience what we call time travel. The paradoxes this creates are mind-bending. Could someone return to a moment before they left? Could the past and future influence each other through these hidden passages? These questions remain unanswered, but they spark wonder and invite reflection on the nature of time. Even if wormholes never exist in reality, they serve as symbols of curiosity and hope. They remind us that the universe may hold shortcuts, hidden doors, and surprising connections. They encourage us to think beyond what seems possible and to imagine realities that are richer than the one we see. In this way, wormholes and black holes are not only scientific ideas, but also metaphors for discovery, for stepping into the unknown, for trusting that the universe has more to reveal. Astronomers and physicists continue to search for signs that such gateways might exist. They look for unusual patterns of light, for ripples in space-time, for anything that might suggest connections beyond the ordinary. None have been found, but the search itself is part of the beauty. The act of wondering, of looking, of reaching beyond, is what keeps science alive. The universe does not give up its secrets easily, but it rewards those who ask questions with glimpses of deeper truths. As you rest tonight, let your mind drift through these possibilities. Picture a black hole not as a dead end, but as a doorway. Imagine stepping close, feeling gravity pull you inward, and then emerging not in darkness, but in light, in a distant galaxy filled with unfamiliar stars. Imagine traveling through time as though it were space, arriving in the past or the future with a single step. Imagine that each black hole is both an end and a beginning, both a shadow and a bridge. There is no need to decide whether these visions are real. Their power lies not in proof but in wonder. They remind us that the universe is greater than we can see, that possibilities are always larger than facts, and that dreaming is itself a kind of exploration. The very thought that black holes might be gateways is enough to inspire us, to calm us, to fill us with a quiet awe for the mysteries of existence. So as you breathe slowly and drift toward sleep, carry with you the thought of hidden roads through the cosmos. Roads that connect stars and galaxies, roads that tie together beginnings and endings, roads that may not exist in reality, but that exist in our imagination. Let the possibility soothe you. Let the vision guide you into dreams where doors open, paths unfold, and the universe reveals itself as a place of endless wonder. Black holes are more than mysterious objects. They are laboratories where the laws of physics are tested to their limits. Everywhere else in the universe, the rules of nature behave predictably. Gravity explains the orbits of planets. Quantum mechanics explains the world of atoms. Thermodynamics explains the flow of energy. Yet at the edge of a black hole, these rules no longer align smoothly. They begin to contradict one another, leaving us with puzzles that challenge our deepest understanding of reality. At the heart of this puzzle is the singularity. According to general relativity, the singularity is a point where density becomes infinite and space and time collapse into nothing. The equations describe a place where gravity overwhelms everything, where our familiar laws break down. But infinity is not a number that nature tolerates easily. It is a sign that our theories are incomplete, that something new is needed to describe what truly happens inside. The singularity is both a destination for matter and a frontier for science, a reminder that our understanding of the universe remains unfinished. General relativity is our best description of gravity, but it does not work well with quantum mechanics, the theory that governs the very small. Gravity bends the large structures of the cosmos, while quantum mechanics describes particles and forces at the tiniest scales. In most places, the two theories do not overlap much, but inside a black hole they collide. Gravity crushes matter into unimaginable densities, while quantum effects swirl at the smallest scales. To understand a black hole fully, we need a theory that unites relativity and quantum mechanics, something physicists often call quantum gravity. That theory does not yet exist. One of the paradoxes that arises from this clash is the information problem. When matter falls into a black hole, it seems to disappear forever. The shape, structure, and information about it are lost. Yet in quantum mechanics, information cannot be destroyed. The contradiction is profound. If black holes erase information, they break the rules of quantum physics. If they preserve it, we cannot yet explain how. Some theories suggest that information may be stored on the surface of the event horizon, encoded like a hologram. Others propose that it leaks out slowly through Hawking radiation. But no answer is complete, and the paradox remains one of the greatest mysteries in science. This tension between theories is not a failure but an opportunity. Black holes point us toward the need for new physics, a deeper understanding that unites the forces of nature. Just as the discovery of gravity once reshaped our view of the cosmos, so too might the study of black holes lead us to new laws that explain the universe more fully. They are not obstacles but doorways, showing us where our knowledge falls short and where our imagination must reach further. Another limit of physics revealed by black holes lies in the nature of time. In everyday life, time flows in one direction, from past to future, carried along by the increase of entropy. But near a black hole, time stretches and bends in strange ways. For the distant observer, a traveler falling toward the event horizon slows until they appear frozen. For the traveler, time continues normally, carrying them inward in a short journey to the singularity. These two perspectives cannot be reconciled easily. They are both true and yet contradictory, a reminder that our perception of time is relative, not absolute. Even energy itself behaves strangely near black holes. Hawking radiation suggests that black holes slowly lose mass, evaporating over immense timescales. If this is true, then black holes are not permanent prisons for matter, but temporary objects that eventually vanish. This raises another puzzle. If black holes evaporate completely, where does the information they consumed go? If it vanishes, physics as we know it is incomplete. If it remains, we must find a new way to describe how. The answers lie hidden in mathematics we have not yet discovered, but the questions guide us toward deeper truths. The study of black holes also forces us to reconsider the boundaries of reality. What happens beyond the event horizon is hidden from us, sealed away by gravity itself. We cannot send signals out, we cannot receive messages in, and we cannot see directly. For all practical purposes, the inside of a black hole is another world, cut off from ours. Yet in our imagination, we can step inside. We can picture the journey inward, the warping of space, the stretching of time, the approach toward the singularity. In these visions, science and wonder meet, each pushing us to imagine what lies beyond. The edge of physics is not a place of despair but of beauty. To know that our theories do not yet explain everything is to know that there is still mystery in the universe. Black holes stand as silent teachers, reminding us that we do not yet understand it all, that there is more to discover, more to learn, more to wonder about. They are humbling, for they remind us of our limits, but they are also inspiring, for they invite us to expand those limits. As you drift into rest, think of black holes not as places of destruction, but as places of possibility. Imagine them as signposts, pointing the way toward new theories, new mathematics, new ways of seeing the universe. Picture the singularity not as an end, but as a question mark, a symbol that invites us to keep asking, keep exploring, keep dreaming. Picture the event horizon not as a prison wall, but as a veil, behind which truths await discovery. Let the paradoxes soothe you. Let the contradictions remind you that mystery is not something to fear, but something to embrace. The universe is not meant to be fully solved at once. It is meant to unfold slowly, to reveal itself piece by piece, to leave us always curious. Black holes are part of that unfolding, part of the eternal invitation to wonder. So as you breathe and close your eyes, carry with you the thought that the greatest mysteries are also the greatest gifts. They remind us that the universe is alive with questions, that even the darkest places shine with meaning, and that in every limit lies a new beginning. Black holes, perched at the edge of physics, are not barriers, but gateways. They are reminders that knowledge is never complete, and that the beauty of the universe lies not only in what we know, but also in what we have yet to discover. The universe is filled with black holes, many hidden from sight, but some have become famous in both science and imagination. These black holes stand as milestones in our understanding, each one a story of discovery, mystery, and awe. By following their tales, we not only learn about the cosmos, but also about the human spirit of curiosity, which refuses to rest until the darkness is illuminated. One of the most well-known black holes is Sagittarius A, the supermassive black hole at the center of our own Milky Way galaxy. For many years, astronomers suspected that something massive lay hidden at the heart of the galaxy, but they had no way to prove it. Then came careful observations of stars near the galactic center. These stars were seen to orbit at tremendous speeds, whipping around an invisible point with such force that only a black hole could explain it. By tracking their movements for decades, astronomers revealed the presence of a black hole with a mass of 4 million suns. Sagittarius A is quiet most of the time, but every so often it flares with bursts of energy as clouds of gas drift close. Though it lies 26,000 light-years away, it is our closest supermassive black hole and a constant reminder that we live in a galaxy shaped by an unseen giant. Another black hole that captured the world's imagination is the one at the center of the galaxy called Métis 7. This black hole became famous not only for its size, but also for being the first black hole ever imaged directly. Using a network of telescopes across the Earth, scientists created a picture of its shadow, a dark circle surrounded by a glowing ring of light. That image, released to the world, was a moment of wonder, proof that what had long been imagined could finally be seen. The Métis 7 black hole is enormous, containing the mass of several billion suns, and its influence stretches far across its galaxy. It powers jets of energy that stream outward for thousands of light-years, shaping its galactic environment in ways both fierce and beautiful. Cygnus X1 holds another place in black hole history. Discovered in the 1960s as a strong source of X-rays, it became the first widely accepted stellar black hole candidate. Observations showed that a star was orbiting an unseen companion with a mass too great to be anything but a black hole. For decades, Cygnus X1 stood as the prime example of what happens when a massive star collapses into darkness. It also sparked debates and inspired generations of scientists to explore the hidden world of compact objects. Today, it remains one of the best-studied stellar black holes, still shining with the X-rays of matter falling into its grasp. There are other black holes that tell quieter but equally important stories. In the galaxy NGC 6240, two supermassive black holes were discovered orbiting each other after their host galaxies collided. These black holes are slowly spiraling closer together, destined to merge into a single, larger black hole. The discovery of such pairs confirms that galaxy mergers are not only about stars and gas, but also about the union of the black holes at their centers. One day, their collision will send out gravitational waves powerful enough to ripple across the universe, adding to the cosmic symphony we can now hear with our instruments. Some black holes are known not for their size but for their unusual behavior. One example is the black hole V404 Cygni, which flares with bursts of X-rays as it feeds on matter from a companion star. These flares are irregular and dramatic, lighting up space in sudden flashes. Watching V404 Cygni is like watching a heartbeat, each flare a reminder of the restless nature of black holes as they feed. Another is GRS 1915, famous for producing jets that flicker on and off, revealing the complex processes that occur in the swirling disks of matter near event horizons. Each of these black holes, whether near or far, large or small, reveals a different face of the same mystery. They are not just points of gravity, but stories written in light, energy, and motion. They remind us that black holes are not theoretical abstractions, but real objects that can be studied, measured, and sometimes even seen. They are not just symbols of mystery, but also of discovery, proof that the universe can be both strange and knowable at the same time. Beyond science, these black holes also live in our imagination. Sagittarius A has become the silent heart of our galaxy, a character in countless stories of exploration and cosmic wonder. The image of Métis 7's shadow became a symbol of human achievement, a photograph that captured the public imagination and inspired awe. Cygnus X1 has appeared in songs and stories, proof that black holes are not only scientific objects, but cultural ones too. They have become metaphors for the unknown, symbols of mystery, and reminders of the power of curiosity. The stories of these black holes also show us the patience of science. The orbits of stars around Sagittarius A were tracked for years before the black hole was confirmed. The image of Métis 7's shadow took decades of planning and cooperation between observatories around the world. Discoveries like Cygnus X1 came only after years of refining instruments capable of detecting X-rays from space. Each of these stories tells us that the universe does not reveal its secrets quickly, but with patience and persistence, even the darkest places can be illuminated. As you reflect on these stories, let them soothe you. Imagine Sagittarius A at the heart of the Milky Way, quiet and patient, holding the galaxy together. Imagine the shadow of the Métis 7 black hole, glowing softly with the light of gas spiraling into darkness. Imagine Cygnus X1, a star circling its invisible companion, each orbit a silent testimony to the presence of gravity beyond sight. Imagine distant galaxies with pairs of black holes circling each other, their eventual embrace destined to ripple across the cosmos. These famous black holes are more than astronomical objects. They are markers on our journey of discovery, milestones that remind us how far we have come and how much there is still to learn. They are both destinations and beginnings, both mysteries and revelations. In their presence we feel small, but we also feel connected to something vast, a universe that holds us in its embrace. So as you rest, let these stories settle in your mind like stars in the night sky. Let them remind you that even the darkest places hold light, that even the most mysterious objects can be known, and that curiosity is its own kind of courage. In the end, black holes are not only about gravity or energy or light, they are about the endless human desire to look upward, to wonder, and to dream. As we come to the end of this long journey through the mysteries of black holes and the wider cosmos, let us take a moment to pause and reflect. Over these hours, we have drifted across stars and galaxies, wandered near the edge of event horizons, listened to ripples in space-time, and pondered questions that stretch beyond the limits of human knowledge. Black holes, once thought of only as strange curiosities of theory, have revealed themselves as quiet guardians of galaxies, fountains of energy, teachers of physics, and symbols of mystery. At their heart lies a paradox that is both humbling and comforting. They are places where gravity is so strong that not even light can escape, yet their surroundings shine with some of the brightest light in the universe. They are regions where time itself slows and bends, yet they also carry us forward by pointing the way toward new physics and deeper understanding. They are destroyers and creators, endings and beginnings, silence and music all at once. To think about them is to see that the universe is never simple, never just one thing, but always a balance of opposites woven into harmony. Black holes remind us of how small we are and how vast the cosmos is. They contain millions or billions of suns within their grasp, while we live upon a small planet circling a single star. And yet, the same elements that swirl in accretion disks and flare in jets are the elements within our bodies. The iron in our blood and the calcium in our bones were forged in ancient stars, scattered across galaxies by processes that black holes help to shape. In this way, the story of black holes is also our story. We are not separate from the cosmos, but part of its endless cycle of creation. They also remind us of the patience of discovery. For centuries, black holes were imagined only in equations. No one had ever seen one or had proof that they were real. Yet curiosity did not rest. Astronomers measured the motion of stars, the flicker of X-rays, the bending of light, and the trembling of space itself. At last, the image of a black hole's shadow was captured, a picture of the impossible, a vision of darkness surrounded by a glowing ring of light. That moment was not only scientific, but also deeply human. It showed us that with persistence, cooperation, and imagination, even the most hidden truths can be brought into view. And perhaps most of all, black holes remind us of mystery. For all that we have learned, questions remain unanswered. What lies beyond the singularity? How is information preserved or lost? Could black holes connect us to other universes? Will they one day evaporate, leaving only whispers of their existence? These questions do not weaken our understanding, but deepen it. They remind us that science is not about final answers, but about an endless journey, a path that always leads onward to new discoveries. In that journey, we find wonder, humility, and peace. As you listen to these thoughts, let yourself drift into calm. Picture a galaxy spread across the night sky, its arms glowing with billions of stars. At its heart rests a supermassive black hole, silent and steady, guiding the dance of light. Picture smaller black holes scattered throughout, remnants of stars long gone, their invisible presence shaping the paths of their neighbors. Picture jets of energy stretching outward, gravitational waves rippling across the cosmos, time slowing and bending at the edge of darkness. All of this is real, and all of it is part of the same story, a story that includes you. There is comfort in knowing that the universe holds mysteries too vast for us to fully solve. It means there will always be wonder, always more to learn, always more to dream. It means that even as we rest, the cosmos continues its slow and graceful dance, galaxies turning, stars forming and fading, black holes keeping silent watch. We are small, yes, but we are also witnesses, able to see, to imagine, and to feel awe. That ability itself is a gift, as rare and beautiful as any star. So as this narration comes to an end, let your thoughts soften. Let the images of black holes fade gently into the background of your mind, like stars dissolving into night. You do not need to solve their mysteries. You do not need to carry their weight. You can simply rest in the knowledge that the universe is vast, balanced, and endlessly mysterious, and that you are part of it, safe within its embrace. Breathe deeply. Feel your body grow heavy and calm. Imagine yourself drifting among the stars, carried by the quiet currents of gravity and time. You are part of a story that stretches across billions of years, and yet in this moment, all you need to do is rest. The mysteries of black holes and the cosmos will remain, waiting for you, when you awaken. For now, let them be gentle lullabies, soothing reminders of wonder and peace. Good night. May your dreams be as deep as the universe, as calm as the silence between stars, and as endless as the mysteries that surround us. Sleep well, and let the cosmos keep watch over you.